But you could be warned about a mountain lion, but when you're on the cross one, it's like, whoa. So, it's not quite a mountain lion. This problem says a lot. It's got a lot of shit going on. Can anyone, does this problem look familiar to anybody? Have you guys, anybody gotten here yet? Some of you guys are like, slow down, boy. Okay. So, read through that problem really quickly. And what I want to know is, how many probabilities does it tell me directly? It just tells me
3.
more. It tells me more than 3. There's a quick one. They write all of them as percentages except for one.
Oh.
6 and 10, which is 60%, correct? They're doing that just to be all, ooh, look at us, right? Let me stop for a minute. You guys, everybody see that? There are 4 percentages that relate to situations, which means they are probabilities. That's the percentage of time that something would happen, right? Using these letters, without even looking at the problems, what is the probability of C?
C. 61.
0.61. See that?
Yes.
Look at this next thing. The very next thing they tell me is 18 to 39, 78%, right?
Mm-hmm.
Okay. Among 18 to 39-year-olds, anybody have a clue what the word among would mean?
Given.
Not amongst us, but, huh?
Given.
I mean, it's a given. It's another name for given. Among these people, given that you have this kind of person. Are you guys semi with me?
Yeah.
Okay. So among 18 to 30, so given A, the approval rating, okay, C given A is where'd it go? 7.8.
Yeah.
Are you guys all with me so far?
Uh-huh.
And then just keep going, right? Before you even look at the problems. But if you do look at the problems, the first 4 questions they ask, there is 0 work to be done. Didn't we just figure out what the probability of, what did we just figure out? I forgot. C.
0.61.
We figured out probability C. Did we just figure out the probability C given A?
0.7.
We didn't figure it out. We just saw it. So they give me 4, everybody with me, they give us 4 percentages
Yep.
that relates to 4 probabilities. And those probabilities are the first 4 questions. There's no work to be done for these. You guys understand? Do you guys understand?
Yes, sir.
I still see some pained looks. B is registered voters who said the Supreme Court's ruling about the constitutionality is very important. So the ruling is important.
0.6.
Okay. So this is 6 and 10 said that the ruling was somewhat very important to them. So that probability of B is 0.6.
Yeah.
And that's question B. Do you see what I'm saying? So every one of those 4 first questions, no work. You just have to go find it. Then you got all the raw material you need to answer future probability questions. What's the formula for probability of C and D?
C given B times C, or B given C times D.
Sure. So it's going to be the probability of one times the probability of the other one given the first dude. Either which way. Now looking at the first 4 questions, looking at the first 4 questions, which one of those 2 can I use? Why the second one?
I mean the first one.
Okay, why the first one?
Because it already gives.
Because we know B given C. Do you see that? Does everybody see that? The first 4 things, A, B, C, D, are all things they just give me. The first probability question I actually have to work on is the probability C and B. There are 2 options. Is everybody cool with this? There are 2 options for its formula. Which one do I use? Well, which one do I know shit for? I don't know, what was it? I don't know C given B. I don't know it. So of course I'm not going to use this one. I know B given C, don't I? Isn't that one of the first 4? That's one of the ones they just told me.
Mm-hmm.
Are you guys at all with me here? So if I give you a situation, I just say 39% of people like lemons or whatever. So P of L equals 0.39. You immediately write that shit down as you're reading through it. Before you even look at any question, you just collect all the stuff you know. Does that make sense?
Mm-hmm.
Because then when they ask me a probability question, I just put the shit in the right place. Maybe. It feels like algebra to a certain degree, because what you do in algebra is you have this formula with all these letters, and then a word problem comes along and you start plugging numbers into the right place. That's pretty much exactly what we're doing. Yes?
Are all of them going to be like that though, or some of them you're not going to have anything given to us?
You have to be given something. So there's two main types of probability questions like this. Either I give you a chart or something, I give you some way that you can count everything you need. And then I don't even need the formulas, right? Is that cool? Like the very first table we did, we developed the formulas based on what we did. I didn't need the formulas. Are you guys with me? Because the idea of probability does not change. The formulas look weird because they have to handle every situation, so they're going to look weirder than they have to, right? So either it's going to be that kind of problem where I give you everything you need to count, in which case you need to use no formulas. You just, the number that matches what you're looking for divided by the total number it could be, right? Or it's going to be a problem like I just say, 73% of people like to go water skiing, blah, blah. So then you put P of W equals 0.73. You kind of with me? And then it's more like algebra where you plug shit in the right formula and you solve for what you don't know. Yeah.
Aren't you like, remember 88
All right, so 88, right? So let me give you a little word about 88. Don't worry about part C. I have no idea what happened to the people that wrote this book. On part C does not flow. Were part A and B okay? Or was there a problem with? Oh, okay, so first thing is sample space. So this is one of those things that kind of left for your reading, right? Sample space is just the collection of all the things that can happen. You with me? So if I pick two cards with replacement, one thing that could happen is ace, ace. Is that cool? Comma, ace, king, comma, and that would just keep going, and that would be a pretty big frickin' sample space if you think about it. Are you with me? That'd be huge. If I roll a die twice, what are some things that could happen? 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2. Do you see what I'm saying? So then you can make the sample space. So here, thankfully, it's nowhere near as much. I am rolling a die and then tossing a coin. Give me one thing that can happen if I conduct that full experiment. Yeah, I could get a 1 and then a heads, or a 2 and then a heads, and then a 3 and then, or then a 1 and a tail, or a 2 and a tail. So it's really pretty quick. If you do it in an organized way, you can make the sample space pretty easily. Does that make sense? Mm-hmm. So I didn't really say directly what the hell a sample space is, but that's all it is. It's just a collection of all the things that can happen. Okay. I lock it. Yeah, okay. And the way to do part B, is there anything in that sample space that would be more likely than anything else? Is it more likely I get a 2 and then a tails than if I get a 4 and then a heads? Is it more likely?
No.
No. The probability to get any number on a die is what? 1 out of 6. The probability to get a tail or a heads is what? 1/2. So what's the probability I get a 1 and then a tail?
1 out of 12.
Where'd 1 out of 12 come from? Where do you get that? 1/6 times 1/2, because I want a 1 and then a tail, I think is what I said. I can't remember. Right, 1/6 times 1. So every single element of the sample space will have a 1/12 probability. Does that make sense? Mm-hmm. Which also makes sense because do you guys know how big the sample space would be? 12. So any one of them has an equal probability, 1 out of 12 chance. So there's 2 ways to see why it's 1 out of 12. Is that all right?
Yep.
Okay, that was definitely one of the freakier ones because that's one of the ones related to something I just didn't tell you about. I do leave a few things for you to read about. Because I always like to say the complete class is me plus book. Me plus book, right? Okay. Anything else from homework stuff specifically? Anything from the practice quiz? Anybody still need a practice quiz that came in after I gave some out? Does everybody have that? It looks something like, shite, I just hit a button, I don't know what it did. Okay, it looks like this. One side looks like this. And then the other side is the practice probability quiz. By the way, I don't know if anybody went to Canvas today, but I put this sheet and the answer key up in Canvas. Is everybody with me? Did anybody see that in Canvas? You did? Thank God. Okay, good. So I actually did it. Yeah. Oh, you saw it? Okay, thank you. So I have the answer key up there. I'm just trying to save some paper. My God. Anything I print out for you guys, I double it because I have another stats class. So it's like, wow. So the key is up there. If you have any questions from the practice quiz, we can do it right now. Yes?
For 2B, the answer would just be 0 because the chance of selecting the second butterfinger would be 0 over 11, right?
To which one?
2B.
2B. Oh, beautiful. Not 1B. So now we got to be a little bit like a lawyer, right? Because this is with
sorry,
replacement.
2B.
2B, I got you. So this right here, I pick a Butterfinger and I eat it because I'm not replacing. Then I get a Twix. How many Butterfingers are left for me to pick on the third go? None. So how is this possible?
No.
Nope. Given that that's my universe. That's it for me, right? Why is it okay for the first piece?
There's more than one.
Because I don't eat it. I put it back in, right? You guys with me? I guess I'm trying to get a Snickers and I keep getting Butterfinger and Twix. I'm like, damn it, damn it, damn it. You guys semi with me? I must be in a dark room or something. I don't know. Trying to go by smell. Okay. Anything else? Any other question? Right now is the time to get it out because this is the review section before our quiz on Wednesday. Yes?
Can you explain the independent, dependent?
Yeah. So, independent means if something happens, here, let me put it up here. If an event happens, an event occurs, right? And another event doesn't change its probability. So right now, a tree just fell in somebody's yard. Maybe. Did that affect us at all? No. So our state of being is independent from the probability a tree just fell in somebody's yard 300 miles that way, right? Those are independent. I'm not going to get in the whole butterfly effect bullshit. All right. There's a lot of cool shit to talk about. This is not the class for it. So from if I ask you, can anybody tell me this? You know I'm going to ask you, are these two things independent? Does anyone have a clue what to even check? How do you test to see if two things are independent?
I don't know. You get the percentage of the given, right? And then
All right, so
just
if
see
the
it
probability
equals-
of A given B,
and then it's equal A.
yes, that's really, guys, you don't have to say this out loud, but you can say it out loud. Can you read this for me? What's it say?
Probability of A given-
Stop. So it's the probability of A. That's the main question, correct? And that's also the probability of A, correct? These are both probability of A. Over here, I just happen to know that B happened. If B happens and the probability of A does not change, shouldn't we call those independent? Doesn't that just make sense? It didn't give a shit that the other dude happened, right? Maybe. So, again, I've said this before, but if I ask you, are these two things independent, and you find yourself writing a lot of words, you are wrong. Stop. The answer to the question is not a lot of words. The answer to the question is, show me what this is, and show me what this is. If they're equal, they're independent. If they're not equal, they're dependent. Is that any better? Or still like, you said that before, man, can you say it a different way? Or where are we at with that? Yeah.
So 4A would be
A, that one's a little bit on the nose, because I already did all the work for you, right?
Right, yeah.
But the probability of A given B is 0.85, and the probability of A is 0.8. So obviously, if B happens, that increases the chances that A happens. So, if you see clouds in the sky in the morning, does that increase the probability that people have umbrellas later? Don't you agree? Yes, right? I know we live in San Diego, where an 80% chance of rain means it might drizzle, if anything, right? Okay, right, but still, wouldn't it would increase the probability that somebody will have an umbrella, correct? So those would be dependent events. The probability somebody has an umbrella depends on what it was like when people were leaving their house in the morning, right? That makes sense, correct? So what does that mean mathematically? The only probability we calculate that takes into account the effects of one thing on another one is the given. Given this dude happened, what are the effects it has on this other dude? That's basically what a given is. So again, just remember this, I'm still gonna have people do this, but if I ask you, are these independent, and you start writing a lot of words, erase that shit. You are wrong. You're gonna start writing stuff like, well, no, you don't have to actually have a cloud, you can bring an umbrella if there's no, that has nothing to do with the question of independence. If two things are independent, let me think. If something is dependent on something else, that doesn't mean it needs that to happen to even have a chance to happen or so. I think people get that confused. Just does the probability change if something else happens? So if you forgot to eat lunch and then you have a test at 2 o'clock, will that possibly affect how you do on the test? Those are dependent events. Does that mean that you're doing well on the test? That cannot happen unless you eat lunch. Is that what that means? No, it just means that the probability you do as well as you could have is lower now, right? Because you didn't have lunch. And the freaking tummy is like, shut up. Okay. And of course, the people sitting next to you, just stomach's going, rah, rah, rah. They're probably going to do a little worse too. There you go. Is that all right? All right, I'll stop harping on that unless somebody asks a follow-up question. If it still doesn't make sense, feel free to follow it up. Anything else?
Are you gonna do it, or
Am I gonna do what?
any of them?
I did them all.
Oh,
Where are the answers at?
on campus?
On campus, sorry.
Right, okay.
But again, if you want to do any right now, that's what this is all about.
Is
yeah.
it .073 for 3, A?
What is it?
.073?
I have no idea. So it'll be yeah.
0.33 times 0.33 times 0.67.
So it'll be 1/9, 1/27, which is 1/3 of 1/9, which is, doesn't sound right, what do you think? First two dislike the plan. So how do you do number 3A?
0.33 times 0.33.
So anytime I give you a problem like that, where I just tell you this percentage do this, and there's a percentage that don't do that, correct? In part A, do you see the word and anywhere? But it's everywhere. The word but is and. The word but is just another way to say and. You replace but with and everywhere you see it, it's going to work still. Beauty. So the probably the first two disliked plan, and the third one liked it. Still works, correct? And the first two dislike it. That means the first one dislikes it, and the second one dislikes it. Are you guys with me?
Yeah.
What does and mean?
Times.
Multiplication. So I have one person, one person, one person. The first two, where'd he go? Dislike the plan. What's their probabilities then?
0.33.
3, 3, 3, and the last one likes it.
0.67.
Where'd 0.67 come from?
The other. 1 minus 1.
If one of them's 33%, so probably not that, must be the rest, correct? 67%, okay. Real quick, you don't have to do this, but isn't this another way to write this? Bryce? I want to point out this means 2 don't like it, 1 likes it. That's how to read that. That's almost too nice to believe. Throw that shit in the calculator or whatever you get.
0.073.
Okay.
Alright.
2. Yep.
0.31 minus.
I'm not sure how many of you guys tried the cracked this thing out yet. I'm not sure where you are in the homework. Don't forget this. The homework, again, is not due until the day of the test. But by Wednesday, you should have tried problems from every section in chapter 3. You with me? So if you're just now starting to do 3-1, Wednesday's coming. So stop trying to do every damn problem right now. Just do every other one or whatever. Get some from every section in chapter 3, get some done. You're that much more ready for the quiz, and you can finish that shit up later. Does that make sense? I'm still gonna be like, hey, finish this, what the hell? And you're gonna be like, all right, Jeff, calm down. Right? I mean, again, as part of my job is to keep you on track and to make you do stuff, blah, blah, blah. Your job is to make all that shit into your own. Right? I sure did, man. My homework grade was horrible. Because I didn't have time. I was working 3 jobs. Right? So you just do as much as you can to get ready for the test. The heaviest weighted stuff, right? Okay. Now I didn't just say, if you don't do the homework, it's fine, did I? Okay, good. I always get somebody say, I heard you in class, you said, just do what you can. No. But you do as much as you can. That's it. Anything else? And then I want to make sure we have the right formulas on our sheet. So let's talk about the formulas real quick. There's only 3 formulas, really. What was the problem, A or B? What's or mean, basically? Add. I love it. If you remember nothing else, but or means basically add, and means basically multiply. That's good. Not great. Nowhere near great, but it's good. Right? Those are 2 of the most important things to come out of this section, because I'm going to refer to that so much in the very near future. What about probability of A given B?
Probability of A and B.
Yeah. So it's the and divided by the given. I love it. And then, of course, probability of A and B is the one that sucks a little bit because it's got 2 ways to do it.
A given B over A.
No over anything. What does that line there mean again?
Given.
Does it mean division at all? Nope. Okay.
So we can have that written down on a piece of paper, right?
Just like the first test. This is the formula sheet for this double quiz. You could add these to your old formula sheet, so then by the time of the final, you just got all the formulas, right? You can have a separate formula sheet for everything. I don't care. You could bring in as big of a freaking formula sheet as you want, as long as it does not bother anyone else near you. Does that make sense? Or away from you, right? I don't require you to have. You can have every example you want in this big of a paper. Ha ha. Yes, come on, that's just silly. Okay. Is that all right? Anything else you think should be on there? Any other formulas you think should be on there?
How about like the independent and mutually exclusive?
Those are not formulas, those are ideas.
Do we have ideas?
Nope. Stop having ideas. Stop it. That's dangerous. No ideas allowed. All right. So again, we had a big discussion in my first class about independence versus mutual exclusive, right? Let me ask a question from the homework for you. How did this section here go? I think I made a big enough, what was it, 40 something. So that would be in, anybody tried these problems out yet? Oh shit, y'all can say, Jeff did. You cannot see what you're talking about. These problems here. Anybody try those yet?
Yeah.
Yes?
I was confused on 43.
Say again?
I was confused on 43.
Oh yeah, 43, okay. Notice, I'll do 43 in a second. Notice every single one of these. The very first sentence is the most important sentence in every single one of those problems. And some students just kind of go past that. Your brain says, I don't see any numbers. How could they have a problem? How? This is a math class. I don't see any numbers there. Does anyone know what I can immediately write down if I tell you that formula sheet, right? See how it's way over there? It's not going to stay there. Okay. If I tell you that L and P are independent, does anyone know what you can immediately write down? What does that mean is true?
L, yes, P of L equals P of L given P.
Yeah, P, I can write down P of L equals P of L given P. I can also write down P of P equals P of P given L, right? So everywhere you see that say, these are independent events, you can immediately write down those two facts. If they're independent, that means if one happens, the other one does not give a shit. Do you guys really see how that's what that says?
And also P of L and P equals P of L times of P times P.
Sure, that's just a secondary thing from this being replaced with that. I agree. But that's the immediate thing you can write down. Are you guys kind of with me? What about mutually exclusive? What's the immediate? So if I said M and F are mutually exclusive, what can I immediately write down?
P of M and F equals 0.
P of M and F equals 0, right? Okay. Just to make sure everybody understands, I chose letters at random. I'm not trying to make any statement about anything. M and G there. So if I say mutually exclusive, that means they cannot occur at the same time. I'll lock it. Now, second rung. So for example, on number 40, what can you immediately write down after reading the first sentence? What's 0? From just the first sentence, what can you write down?
E and F.
Probability of E and F equals
0.
0. Now, what do they ask you for?
E given.
What's the formula for E given F probability? Probability E and F divided by probability of F. It almost doesn't matter because what's probably E and F? What did we just say?
0.
Holy shit, see? So that first sentence is the most important sentence. Then they ask you a question, you write the formula for what they ask you, and then you can throw that stuff in. Do you guys see that? So if you skip that first sentence, you're going to be lost. You're going to be lost. One big mistake I see is on number 42, for example, probability U and V, people just take this one times that one. Is that the formula for probability U and V? Nope. And that's only true if they're independent. What is the formula for probability of U and V?
U given
U times
U.
V given U. So when would it be probability U times probability V if they were independent? Because V given U would equal probability V then. That's the only time you can just straight up multiply them, which is related to what you said. Okay, maybe.
So then for 41, the answer would just be 0.3 because probability.
Shit, yeah. If they're independent, probably J given K equals probably J. So 41 becomes silly easy if you don't skip over that first sentence. You guys see that? Okay, so this is a really rough section for people that don't realize that first sentence is everything, right? Okay, and I'm putting way too big of a point on that. That's just the way those work. Okay. 43, what I just said is really related to 43. Real quick, remind me probability of A and B. And you're all like, it's right there, Jeff. Okay. So it'd be probability of A times probability of B given A, for example. If A and B are independent, what does that mean? What's probability of B given A?
Then equals P of B.
So then what's probability of A and B? How can you write that now? probability A times probability B. Right? Now replace A and B with Q and R, and you got that problem easy. You guys see what I'm saying? A and B, like somebody said earlier, they're just placeholders. Just like X and Y in algebra. You replace them later with letters that make more sense. If you're talking about the length and width, you use L and W. You don't use freaking X and Y, correct? X and Y are just placeholders. You can use more relevant letters. For us, we use capital letters for events, right? And we normally use capital letters to make sense. So Q could be probably you see a quail, and R could be the probably you see a rattlesnake, whatever, right? Does that make sense? So it's better than just A and B all the time. Okay, maybe. All right. Anything else before we move into chapter 4?
Is it quiz on chapter 4 too?
No. I never ever test or quiz you on something you learned the class before.
Thank you.
So going by my 2 classes later idea, didn't we finish up chapter 3 last class? Last Wednesday, correct?
Oh, yeah.
Yes. So when would it be sort of soft due? 2 classes later this Wednesday. So I always schedule quizzes and tests based on when the homework is due, right? Okay, that's enough of that. All right, so we're going to get into chapter 4 because I see nothing else in math. Okay.
What about 100, part 5?
100 what?
Part 5.
Part 5. All right. So this is another good one to just take a minute at the beginning and 0.10 using the letters they choose. How would I designate that with symbols? 0.10. What symbols would you use?
C. Oh, D.
Yeah, so D is the event that a student takes a distance learning class. 10% of students have taken a distance learning class. So P of D equals 0.10. Is that cool? Do the same thing with 40%. 40% are part-time. Part-time is E, so P of E equals 0.4. I like it. I'm not sure why they chose E for that, but I will. And then you can try to do all those. What did we just say earlier about mutually exclusive? What does it take in order for 2 things to be mutually exclusive? The probability of? Yeah, so in this case, the probability of D and E must equal 0.
Okay.
Yeah, and the very first thing you calculate is that, right? Okay. Is that cool? Is that right? Okay. All right.
Thank you.
Anytime. It's like my job. Okay. All right. Okay. All right. So, we got that coming up on Wednesday. We'll do that first thing. Wednesday, we'll just keep going in chapter 4. Today, we're going to try to do as much out of 4.1 and 4.2 as we can. Okay. And let me ask you this. No matter how I give you, let me make sure everybody's really cool. Everybody really cool? Anybody still have questions before I jump into my little spiel? If there's no other questions, just go ahead and put away all that probability stuff. If I give you a big set of data, I don't care how I give it to you. Does anyone know what the 2 most important numbers to calculate are from a quantitative set of data? Good, the mean. Where's the middle? And standard deviation. So I want to know, okay, where's the center of the data and how far does it get away from that center? Those 2 numbers, if I have 1 million data points, you give me just those 2 numbers and I have a decent feel for your data. You guys follow? So for example, if I give a class a test and the average is a 75, but the standard deviation is 6, now for you guys, you don't know this, but after so much time, 6 is really tiny. A normal standard deviation is 14 for a test or quiz. So if I see a standard deviation of 6, that immediately tells me something. I don't have to know every single person's grade. That tells me that what normally that means is there were questions I asked that I didn't really cover too well, because even my really great students screwed up on something because nobody scored a really high grade. Do you guys understand that? If the average is 75 and the standard deviation is 6, 3 standard deviations away is 93. So people just barely got into the 90s. Are you guys semi with me?
Yeah.
Okay, good. Whole point of that is, no matter how people give me data, I want to know how to find those two numbers, those two summaries, right? The mean and the standard deviation. The second thing, I don't know if anybody's thinking about this right now. You're like, how the shit would you give me data, dude? One way I can give you data is the first way everybody imagines. Just a big freaking comma separated list of numbers, correct? And I've done that a lot, correct? That's not the only way to give data. One of the first kind of other ways to give data, turn off this stream stuff. Is if I have data that has a lot of repeats. Why the hell would I say to somebody, okay, here's my data, 0, 0, 0, 0, and you're like, dude, just say 8 zeros or something, right? Like, why are you saying 0? Just say 12 zeros, right? Okay, you guys understand what I'm saying? So let me ask you, if somebody gave me the data like this, what is that? All right, that's fine. Sure, okay. What percentage of the data is 0? 10%. 10%. Does everybody see that?
Yeah.
Okay, this is sort of like a relative frequency chart. That's all percentages are. That's all probabilities are. They're relative frequencies. You guys with me?
Yeah.
Okay. So like 50% was 2 and so forth, right? So what would the heaviest weighted data value be? 2. It occurred the most. It's got the heaviest weight. It's going to pull the average towards it. Does that make sense for me to say it like that? I like to think of these things as having like a gravitational pull. What's wrong if I just add these up and divide by 4? Why is that not the actual average? That's assuming, go ahead.
Because all of them have different frequencies?
Sure, they all have different frequencies. If I assume that I have the equal number of zeros, ones, 2, 3s, that would work. But do I? No. I have 5 times as many 2s as I do zeros. Do you guys see that?
Yeah.
Do you guys really see that, everybody? Okay. Now, I can write a list that would represent this. What's 0.1 mean as a fraction?
1 out of 10.
1 out of 10. So if I wrote a list of data that looked like this: 0, 1, 1, 1. You guys with me?
Yeah.
How many 2s? 5 out of 10, so 5 2s. And how many 3s? 1. What I'm about to do, something I do a lot, and you guys go a little crazy. I'm about to show you why the process we use works. And then the process itself is pretty simple. People often get confused. They're like, why are you making this harder than it really? I'm trying to show you why it works, and then we'll do a problem clean and just do it all the way through. Does that make sense? So I'm about to go through the creation of the freaking formula that we're going to use, right? Which is never pretty, right? First step here is going to be, this is not going to be that bad, though. I don't want to oversell this. It's not going to be that bad. How would we normally, back in the day, how would we have done find the average? Add them up. So can I do it like this, just to be quick? 0, I have 1 0, 3 1s, I have 5 2s, and I have 1 3. Is that cool? Right? Divided by 10. So the old way we would have done it, we can get the answer right now. And this is where people get confused. Why are we doing a new way if the old way is so quick? Well, because this is a very simple thing. Real quick. If I would have put 0.135. What is 0.135 as a fraction?
13.5%.
No, it's not as a percent, as a fraction.
15.5. Oh, sorry.
That's a percent, as a fraction. Tenths, hundreds, thousands, right? So 135 or 1,000. Here, real quick, how many decimal places? So that's how many zeros after 1 on the bottom. 135 over 1000. You guys see that? That's kind of cool. That's 135 out of 1,000. So I'd have to make a list that was 1,000 long, where 135 of them are 0. Do you want to do that? Okay. You guys sort of with me?
Yeah.
This specific data, simple. I wouldn't do any of this new shit to it. I just do what we just did and be done with it, right? But when this gets a little bit worse, I want to have a shortcut, which is basically what we're making. There's a shortcut to get the average. So somebody help me out. What is this when you add it together? 16 over 10, which is 1.6. Is that cool? Is that all right? And just real quick, what is the average of 0, 1, 2, 3? Divided by 2. I mean, no, I'm not sure what you did. So it adds up to 6, correct? Divided by 4. It's 1.5. Is that cool? 1.5. Why is that a little bit bigger than 1.5? Because 2 pulls the average up a little bit. The heaviest weighted data point was 2. So it's going to pull the average up a little bit. Does that make any sense? Higher data values are going to make my average larger. Don't I have more 2s than I do 1s or 0s? So won't that lift the average up a little bit? Okay, that's all a side note. Sorry. Now, the new way to do this is just reorganizing the math we do to make it really frickin' quick in a table to do it. Can't I write this as 1/10 times 0 plus 3/10 times 1? 5/10 times 2 plus 1/10 times 3. Not would you, because none of us would do that shit, because that's silly. But again, we're not doing it to get to the answer, we're doing it to develop a new way to do this, right? Is the math I just did, is it wrong? Good answer. No, it's not wrong. I can make mistakes, but this is not wrong. 1/10 of 0 plus so forth. Is everybody cool with that? Same stupid math. In fact, can't I write this as 0.1 times 0 plus 0.3 times 1 plus 0.5 times 2 plus 0.1 times 3. Do you see how that relates to the elements of the table?
Yeah.
When I just multiply across and add down, I get the same shit, right? So if I'm given this with a bunch of stuff in it and a bunch of ugly looking decimals, I just multiply across, add down. Bam, right? What do you get here? You get 0, you get 0.3, you get 1, so I get 1.3, 0.3, 1.6, which is the same damn thing we got there. Of course it is, because it's the same numbers, yes. Yes? Are you okay? I'm sorry. Do you have a question? No, you're good. Okay. Okay, so now we've got sort of a shortcut to do it. If I'm given it like this, I don't have to create a list. I can just do it straight on this guy. So what would it look like here? Somebody got down to me, that's... Okay. So to reconstruct this, I would just multiply. What would the top of this be? What am I about to do? I'm about to multiply these together, correct? So what would the title of this one be? X times P of X, that's all, right? I'm just going to multiply the X's by the P of X's. And then I get 0, 0.3, 1.3, and if I add those together, I get 1.6. Now that actually is quicker than if I gave you a list, to be honest. That was even quicker, so hey. What is the form, now real quick, what is 1.6 again? That is the mean. I love it, right? So the mean, what did we do to get this? We added up what? All the XP of X's, didn't we? Remember what I told you at the beginning of this class. We're going to see the summation symbol a lot. And if you cover it, you know what column to make. So if I do this, I'm like, oh, I need a bunch of xp of x's. Isn't that exactly what the hell we made? We made a bunch of xp of x's, right? So then when I add them together, that's what the mean is. I can't remember if I used this phrase before. I almost always do. Expected value. So if I, let's see, if I just randomly pick a person, what is the expected height of the person should be around the average height of people, correct? Does that make sense? That's why it's unusual if I get somebody really far from the average, because we expect it to be the average. Does that make sense? You guys with me? If I flip a coin 100 times, how many heads do I expect to see? 50. That's the expected value. That's the average. You guys kind of with me? The reason I'm making a big deal out of this is, what does it look like the first 3 letters are? EXP, expected. It's silly. It's kind of silly. All right, so sometimes in the book, you're going to see them use the words expected value. I'll say expected value sometimes. That's just another way to say the mean or the average. Okay, I like it. I like it, okay. So that's the mean. Would you agree with me that the standard deviation should be expected that it's going to be a little bit worse based on our observation or experience? Hell yeah. Real quick, what was the old formula for the mean? First formula we had, what was it? Really easy, right? What was it? How do you find the average? You add them up and divide by how many? What's the main difference between this formula and that formula? What immediately strikes out at you that's different? There's no n. There's no division by n. You guys agree with me? All right, now I'm going to show you how you're wrong. What's on the bottom of every probability? Always. What's on the bottom of a probability by definition? Total number of things it could be. Isn't that n?
Yeah.
These, I really want you to be with me. These are the same stupid formula. Just the over n is built into that shit. Do you see that? Anybody? Do you have to see that to be able to do anything? No. But they're really the same formula. Just the over n is built into the probability. I always thought that was so cool. Of course, it doesn't take much for me.
I don't know how you did that.
What do you mean?
Like, how you say it's built into it, that how can division become multiplication?
Oh, we did it just a minute ago. I should have kept this up here. Remember when we had, what was it? Freaking hell. 1, 0, and 1.
Oh, yeah.
What was it? 3 1s? Yeah. And then, right, it was divided by 10, and then I made it 1/10 times 0 plus 3/10 times 1.
Yeah.
That's, you can actually see the n getting sucked into the probabilities, right? Thank you. That actually is a good thing to do. I gotta remember to do that next time. You guys semi with me. Is it really important that you understand everything I just said about sucking the n? No, doesn't matter, right? You don't have to remember about sucking in anymore. But it is kind of cool to realize these are the same formula. You can't change a fundamental idea. You can just reorganize the way you do the math. I'll stop. Now, I already built up the fact that the standard deviation is going to be a little worse. We know it is, because the standard deviation formula has to be a little worse because it's a lot more complicated. It just is. Look up what the formula was for population variance. If you don't remember. As I die if you're old. Who's got it? Anybody?
X minus sigma squared.
Not quite. X minus mu
Oh,
over n, right? Is that cool? Let me see if I can jump to this idea without going through all the steps I just did. Remember the mean? The over n is built into the probability. So to figure the mean out, I take every data value and I multiply it by the weight. And then I add those up. So what this is going to do is this is gonna become the sum of x minus mu squared times p of x. Just like the mean becomes the sum of x times p of x. You guys see the symmetry there? So if I multiply by the weight, each one of these, and add them all up, that will be the same thing as the standard deviation. That'll be the variance. Sorry. The over n is built into the p the same way, right? Now, this formula still sort of sucks. It involves a lot of shit, right? So, let me see if I can get you guys to do this. If you saw something like this in algebra, I'm gonna pull that one piece out. If you saw something like that in algebra, what do you think you should do? If I said simplify that, what would you do? I can't square root it. It's like me saying what's 6 squared and you go, square root 6. No, you can't change the problem, right? So how would you do this? If I said do this by hand, what would you do? 23 squared. Do it by hand, what would you do? 23 times 23. Okay, let me ask you again. What would you do for this? Yeah. All right, do it real quick. I'll wait. We have so little algebra. This is just a little bit of algebra. And you're like, shut up, math boy. Just try. I'm not going to look at what you're writing. I promise. Huh? No. You got to FOIL it out. Right?
X squared minus mu squared?
Nope. So real quick, do you guys remember FOIL? Do you remember what it stands for? Does anyone actually use FOIL? Yes. All right. FOIL should never have existed. It's a bunch of shit. Don't I have to distribute the x? I don't need some mnemonic device. What do I get when I distribute the x? X squared minus x, right? Then this guy gets a turn, negative mu gets a turn. It's just repeated distribution. I don't need FOIL, that's crap. Yeah. You don't hear a lot of math teachers say that, I'm sure. But I don't like mnemonic devices where they're not really necessary because it makes a student feel like it's hard, and that's why we had to come up, let me come up with some way. No. Yeah.
Wouldn't the box method be easier?
Box method, sure, whatever. It's fine.
So like it's easier to understand and stuff in this situation.
Watch, real quick. If I said simplify this, what would you do? Would you do a box? No, right? If I say this, okay, now the x gets a turn, the 4 gets a turn. So it's the same thing. It's just distribution. Box method. Does everybody know what she's talking about? If you don't, it's fine. Very fine. Nothing wrong with the box method. Sort of. I personally don't like it.
So x squared minus mu x minus.
Yeah.
mu
So now the
x.
mu gets a turn, right?
Yeah,
Negative mu x. Negative mu times negative mu is
mu squared.
plus mu squared. So then I get this business, right? 2x minus mu squared. Okay. Very exciting, right? Very exciting. You all look appropriately excited. We're not going to do a lot with this. I just wanted you to do that one piece. Right? Go down the grand line. Try to find the one piece. Oh. I like to do that so I can see. Wasn't there times p of x out there, right? Just go with me. I just want to show you where the first piece of this comes from that we're going to use. If you started to distribute this, wouldn't you get x squared p of x? Minus other stuff, right? Do you guys agree with me? Distribute the p through, right? You with me? Isn't there also a summation symbol here? Now here's the weird part. This is the part I'm not going to do because I'm not going to make this suddenly a summation algebra class. You're welcome, right? All this other shit becomes this. This is the exact same formula as this. Okay. So this is what we're going to use to figure out the variance, is this formula here. Right? Now, a really good question I'm sure some of you guys are asking is, what does all this mean for me? Right? What's it mean? Me sitting here, Jeff. What's it mean for me? Okay. Let's come back to this problem over here. I'm going to switch these. oops, I don't want to erase this. So this variance formula, what does it need from me? What column do I have to make to give this what it needs? Well, if I cover that summation symbol, don't I need a bunch of those? Don't I need a bunch of x squared p of x's so I can add them up? Is that cool? Anytime you get a formula with a summing symbol, if you cover the summing symbol, you need a column of that, so then you can add those up. Don't I already have x p of x?
Yeah.
So to get x squared, let me see if you guys are cool with this. There's two ways to do it, but the way I do it is this. I just take L1 times L3. What's x times x p of x? What's x times x? Times p of x. Isn't that x squared p of x? What's wrong with just squaring this? What would you get if you squared this? What would you get if you squared this?
You get the whole thing squared.
Whole thing squared, which is x squared, p squared.
Yeah.
Is that what I want? No, don't do that. I want x squared p of x. Why? Because that's what shook out in the formula, right? If you cover that sum symbol, you need a bunch of these. All right, let me go make a bunch of those. So I can do this. 0 times 0, 1 times 0.3, 2 times 1, 3 times 0.3. If I add those up, I get the sum of x squared p of x. What's this? Let's see. 3.2. I could have made a mistake. You never know with me. Is everything look all right? So I did x times x p of x. I did L1 times L3 to get L4. Oh shit, we're going down. Okay. That was weird. It's like somebody left open the screen door on the sub. It's not good. So now, where do I put 3.2? I'll tell you where to put 3.2 right. So, where do I put 3.2? Isn't that this?
Yeah.
Right? Isn't 3.2 the sum of these?
Yeah.
So I'm gonna put it right there. What's the mean? We figured out the mean. What is it? 1.6. The biggest mistake people make is to forget to square that poor dude, right? Aren't all these values squared?
Yeah.
Shouldn't I then subtract the mean squared to make it even? So at the end, when I square root, the whole thing gets square rooted evenly? But the most common mistake is people forget to square that poor little dude. By the way, I do have a handout with like a fully worked out problem. Let's finish this up. What is 3.2 minus 1.6 squared? What is it? 1.64? Oh. 0.64, that sounds better. So then what's sigma? Oh, this is nice. Right, if you take a square root of that. Neat, I like that. Yeah. You guys semi with me? Okay. By the way, again, these look like they're more than 0.8 apart, but don't forget there are 50% are 2's. So 50% of my numbers are 0.4 away from 1.6. Do you guys see that? Half of my data is 0.4 away from the middle. So the average distance to all the data being 0.8, that makes sense. I got a few things that are further away, but half of my freaking data is 0.4 away from the mean. Do you guys see that? Do you have to know what I just said? Do you have to be able to see that? No, but just to make sure that that even makes sense. Okay, so let me give you this handout. One side is a fully worked out problem, and the other side is what I want you guys to do right now. Yeah, I got it actually here. On the handout, you can see the lists, commands you can put into the calculator if you want to do this in your lists. Everybody already knows one question that's on every test, correct? What is that question? What's the z-score tell me? Someday I'll get over 60% get it right. We'll see. I think. I'm about to tell you something else. I am going to give you a problem like this. I'm going to give you a table where the probabilities add up to not be 1. They add up to be maybe 0.999 or 1.001. Are those invalid because of that? No, that's fine. So how do you answer this question then? You would say the sum is 0.99, which is close enough to 1. That tells me you checked it, and that tells me you know what it's supposed to be. Does that make sense?
Good.
Don't just blindly put sum of px equals 1 because that's what you memorized to write. I need you to actually check it, correct? Does that make sense?
Good.
Also, this other one is kind of silly, but of course all the probabilities have to be between 0 and 1, right? The lowest would be 0, the highest would be 1, so you have to say those two things. Actually check those two things. I like it. All right. So these are exactly the kind of questions I like to ask for these kind of problems. So this side is all worked out. So go ahead and try to do this side. And definitely feel free to like turn around and work with other people if you want to. If you need to borrow a calculator, we could do that. Yeah.
D.
Yeah.
When you're calculating what the, what percentage of the data points are between these two, do I just do, so it will capture these two data points.
So
it's
if
2
you
out of
caught, if you
6.
catch all the 40s,
Mhm.
what percentage have you caught already?
Oh.
Ah, there you go.
So I
So
gotta
you
do
don't
the
have to do like we did before because I calculated the percentages already. You just got to add them up. Maybe I tried this too early. Can you? So here I said how many, not the percentage.
You got 9.4, I got.
All right, guys, I'm gonna catch up to you.
No, you can try.
Oh shit, I never finished this. So if you put this in the list,
If you just, you don't really have to do that, you can just take the points out. Plus zero and,
right? So then you can say, guys, everybody, then you can say L3 is L1 times L2. Do those numbers look familiar? Thank the gods, okay. And then I want to do L1 times L3 to get x squared p of x. You could also do L1 squared times L2, because that's still x squared p of x. You get the exact same numbers. I don't care. Do those look familiar?
Yeah.
Yeah. See the power of doing the calculator, because some of you guys are doing it line by line, which is fine, but if one line goes wrong, the calculator does the same damn thing everywhere. Okay. And now I want to add up, let me show you a little something. I could do the sum, remember? I could add up L3, add up L4 individually. You guys with me? Let me do it once just to show you. So I could go list, math, 5, sum up L3. Does that look familiar? No. And you can do that for L4 too, right? In fact, I could just hit second enter, L4. Bam! Right? Does that look familiar?
Yeah.
Just real quick, I could also do this. Stat, calc, 2 variable statistics, L3 and L4. The sum of x is 45.8 and the sum of y is 2410.89. That's a little gross because you get all this extraneous shit you don't care about. So I understand if you don't want to do it like that. I just want to point out that's another way to do it. So you got, what was it, 2410.89?
Yeah.
And 45.89?
Yeah.
29, same, is kind of neat. Okay. So, first question, verify it's a valid probability distribution, and again, I'm gonna say this one more time, on the actual test, I will put a problem where it does not add to be one. It adds up to 0.999 or 1.001 or something, right? So don't say sum is 1, because then I know you didn't even check. So verify this is valid, so what two things do I have to say?
So P of
Check.
X equals 1.
Sum is 1, and they do add up to 1, thankfully, right? And
Between 0 and 1.
between 0 and 1. Oops. Okay. Technically, I should also say for all x, but if you don't put that, it's fine. I know what you mean. And again, you can say it in English if you want to. All the probabilities add to 1. All the probabilities are between 0 and 1. You can just say it in English. I love it. Okay.
And for that question where it doesn't equal 1, just.
Oh, good.
Yeah.
So if they had added up to be 0.999, let's say, the way to answer this question is the sum of P of X is 0.99, which is approximately equal to 1. That's a quick way to answer that question. It shows me you checked what it was, and it shows me you know what it's supposed to be, right? Which is what I'm testing you on. So it's a beautiful, quick way to answer that question if it doesn't add up to 1. Now, what if you got the sum of P of X was 0.92? What do you think? Is that okay? Hell no. Something went drastically wrong. Okay. Real quick question. Just look at this. What's the probability that a kid said they're gonna retire at age 100?
0.96.
2% chance, correct?
Yeah.
Okay, so very often I'll get a few people that don't know how to read this, which is fine because you don't see this all the damn time. So I wanna make sure everybody knows how to read this by itself. Now, this question says at least 25, so the answer is not 24%, because there's more than just that, correct? At least 25 is all this stuff here, right? So I could add all these together, and a lot of you guys do that. Do you see how I could also just do 1 minus 0.04? 1 minus 0.04 has to be this shit, because all this stuff adds up to be 1, so 1 minus 1 piece must be the other piece. Okay. A lot of inadvertent references to 1 piece, okay. So what did we get for at least 25? Either way you do it, you get 0.964, 96% chance. By the way, who are these kids? What are they thinking they're gonna do?
Retire.
What do they think they're gonna do to do that?
Big YouTuber.
There it is. Nowadays it's a big YouTuber, right? They're like, hey man, I see Markiplier, I see PewDiePie, is that right? Is he still around? That's funny.
Retired.
Sorry, I'm bringing this up, I'm really sorry. Just want to point that out. And then these poor people, I feel bad for them, I'm like, what?
Yeah.
What happened? Now, we've already calculated what this is, right?
45.89.
What's the mean?
45.
45.89. Guys, when you do this, that is nothing. That doesn't mean shit by itself. It's just one piece, again, sorry, of that's inadvertent. One part of the formula you need for the variance. I have to subtract what?
45.89 squared.
Good. The biggest mistake I see is people forget that poor little square dude. I always forget to make sure you can see what I'm writing. And whatever the hell that is, I don't know. 304,979. Okay. So in your paper, you can round if you needed to. If it went on like 8 places, just round it somewhere. In the calculator, you should not round. So in the calculator, you take the square root of all that business, and what do you get? 464. Okay. At least 3 places. So if you go to 4, you're fine. How did all that go? Is that okay so far? And these are the exact kind of questions I like to ask. You've seen this question before, but now it's a little bit different because we do not, before we had to do 2 out of 5 is 40%, we had to actually calculate our own percentages. Aren't all the percentages already calculated out?
Yeah.
So I just have to add up the right ones. So if I start at 45.89, I go down 1 step, 1 standard deviation, where do I end up? 28.425 or whatever? 28.4 blah blah blah, okay. And if I add 1 standard deviation, I end up at 3 blah blah blah, okay. And I always do this for myself, because the question is, how much did I just catch? So give me one data point that we caught. 40. Just that by itself, what percentage did we already catch? 23%. What other data point did we catch? 50. So now together, how much total did I catch? 41%. 23% plus 18%, 41%. Okay, you can make whatever sound effect you want. Well within reason. Okay. Now this last question is a little bit weird. It's kind of a two-stepper. If I would have asked instead, what percentage of kids think they'll retire before 65? What do you have to add up?
Everything.
Everything before 65, so all these. Sorry, can't see that. All these here, right? What do you get when you add those up? So 69%, but I didn't ask for a percentage. I want to know the number of kids. Well, 69% of what? 1,200 kids. And what is 69% of 1,200?
828.
69 times 1,200, 828. So 828 kids think they'll retire before 65. They're most likely wrong. Poor little dudes and dudettes. By the time they get old enough, the retirement age will probably be 70 or something. Okay.
Go be.
Of course, I don't know what's going to happen, but you know. How you guys kind of feel about this? Is this all right so far? So far, so good. Okay. All right. So this is a really good sheet to have sitting next to you as you do the homework. That is actually all I have for today. It's the best thing about this class. You're going to let us out early this long. Thanks for that. Enjoy a little bit of extra free time tonight. Don't forget Wednesdays, the quiz, the double quiz. Don't forget your stuff if you created these. Yeah.
I'll give you twice each time.
Main character we have right here. It's probably going to be 0. You see, mutual exclusive means it's probably going to be 0. It's not 0. It's not mutual exclusive. It goes with.
Thank you.
So,